In this lesson, we're looking at the second law of indices, which is to do with division. When you divide two terms, you can write them two different ways. You can write them like a fraction, like in this case, or you can use the division sign, like in that case. Either way, the answer is obtained by subtracting the powers or indices. Why is that true? Let's look at an example. A to the power 5 divided by a to the power 3 can be rewritten as a times a times a times a times a, which is a to the power 5, divided by a times a times a. If we think of that as just the same as a fraction, we can actually cancel some of the a's out. So by cancelling, I can cancel that a goes into a once, and a goes into that one once, a goes into a once, a goes into a once, a goes into a once, and a goes into a once. Now that simplifies down to just a times a over 1, which is written here. You can see that there are only two a's left, so I can rewrite that as a to the power 2. Let's look at doing the same question but without having to write out the expanded form with all those a's. A to the power 5 divided by a to the power 3 is equal to a to the power 5 minus 3. 5 minus 3 is 2, so the answer is a to the power 2. So the quick and easy way to do it using the second law of indices is to subtract the powers or the indices when you're dividing the terms. Now let's look at some examples. In this example, 25 v to the power 6 multiplied by 8 to the power 8w to the power 9 is all divided by 10 v to the power 4 multiplied by 4w to the power 5. In this example, you can see there's a mixture of numbers and letters. Again, the rule for the second law of indices only works when the letters are the same. So let's simplify this like we did before with multiplication. I'll collect all the numbers together on the left-hand side first. So I've got 25 multiplied by 8, and on the bottom half, or the denominator, I've got 10 by 4. If I look at the v's, there's a v to the power 6 on the top, on the numerator, and a v to the power 4 on the denominator, a w to the power 9, and a w to the power 5. If I look at the numbers, you can see there's some cancelling that can go on there. So let's do that. 4 goes into 4 once, 4 goes into 8 2 times, 5 goes into 25 5 times, 5 goes into 10 2 times. So that means we've got 10 over, I can cancel again. There's 2 goes into 2 once, 2 goes into 2 once, so I end up with just 5. So the numbers simplify down to 5. With the letters, if I look at now the v's, which are these two terms, you've got v to the power 6 divided by v to the power 4, which gives you v to the power 2. And on the next one, I've got w to the power 9 and w to the power 5 for the w's, which will give me w to the power 4. Now, everything on the bottom part of the fraction is 1, so we don't really need that, so I can just rewrite it as 5v squared w to the 4. So you can see the trick with this is to actually just concentrate on one thing at a time. First of all, I looked at the numbers and just did those as if they were normal fractions. Then I used the second law for indices for the v's, and then I used the second law of indices for the w's. Try not to do too many things at once, because if you do too many things at once, you can get confused. In this next example, the actual number part of the question doesn't divide evenly, but that's okay because it's still a fraction. So let's go 7t cubed, or to the power 3, multiplied by 4t to the power 8, divided by 12t to the power 4. This question also includes the first law because we've got a multiplication sign on the top part of the fraction on the numerator. So let's look and see what we do now. Again, the same thing. Let's look at the numbers themselves. So I've got 7 times 4 divided by 12, and t to the power 3, t to the power 8, and underneath t to the power 4 in the numerator, the denominator, sorry. Now, if I look at that, 7 fours are 28, divided by 12 doesn't actually work very nicely. So I'm going to do some cancelling. 4 goes into 4 once, 4 goes into 12 3 times, and 3 won't go into 7, so that's the best we can do. So in terms of the actual numbers, it's just going to be 7 over 3. Let's look at the t's. Over here, I've got a 3 and an 8 on the top, and a 4 underneath. The ones on the top on the numerator, they need to be added because they're being multiplied. So it's going to be 3 plus 8, and the one underneath, the number underneath the 4 is being divided, so its power needs to be subtracted. So really I'm just going to be going 3 plus 8 minus 4. 3 plus 8 minus 4. When you incorporate the ones from below the line, they become negative when you subtract them. So 3 plus 8 is 11, take away 4 is 7. So the power, or the index, becomes 7. So the answer is 7/3 t to the power 7.